Hello and a warm welcome back. Today on the bench, sort of, is a Tektronix 1A1 dual channel plugin. Why am I messing around with Tektronix plugins and all the rest of it, you may well ask. Right, the big green amplifier was doing something it shouldn't have done, i.e. when I applied negative feedback, the high frequency response got worse. The low frequency response got better, but the high frequency response got worse. I've tested various amplifiers over the years and run probably thousands of frequency response tests. Never really seen that before. Why? So part of the answer may be in that at high frequencies, like say about 20k up, there's some sort of phase shift going on, and the negative feedback being fed back is no longer negative, but is sort of a bit positive. But I won't go into that just now. So how do you confirm that? Right, well, you use an oscilloscope or something of that nature. However, this oscilloscope here isn't working properly. This one is, but I haven't got a dual trace plug-in. I did try to measure the frequency difference with a lysogybe pattern, and I'll probably put the video out at some point on that. However, I've still got a problem with the scope. Basically, all these scopes do, they're not calibrated, so all they do is just display an image which could be, or which might or might not be correct. With things like phase angle, we need to make sure that it is correct, and to do that we have to have working plugins. I've got numerous plugins, and that's just a few that I've got. A few sort of work, most of them don't. So what is it doing that it shouldn't be doing? What I've got here is a lead coming from the plug-in power socket thingy over to the plug-in here, so that I can take some voltages. So the scope's warmed up. Right, this is channel 1, and I'm moving the positioning knob, but as you can see here, Tektronix kind of give us some neons that show us where do you call it, a neon to show what is happening, and that neon is indicating that it's up there, and as we can see, it is up there. Right, I'm now going to bring it on channel 2, and we have the same situation. No movement. That's chop. I didn't have that before, and again we've sort of got a bit of movement there. That's actually channel 1 up and down. That's channel 2 up and down knob. Let me just try and sort these traces out a bit, so I don't want to burn the CRT. And let's think this is out, and again we've got a problem. This plugin is a later plugin, although it's an early one, so it doesn't use any traditional thermionic valves. However, it does use new vistas, and they are just there to, they work. We know they work because we've just seen a couple of traces on there. And then there's 3 cards. This is our output card here. There's 2 output cards, one there and one on the other side. I have been over every diode and every transistor and checked them. I can't find ones that are knackered. So what I'll do, sort of fallback position, is to take some voltages, and I've actually read the manual. I mean, you need to with something as complex as this, and then hopefully that will tell me which bit isn't working. Wish me luck. So what I've done, I've sat down, looked at the schematic and taken some voltages that I need to check here and all over the place, and also the Tektronix manual gives you what you should set the vertical plug-in to. So for instance, AC, DC, etc. wants to be grounded, volts per division 0.5 V per div, etc, etc. So I'll go and do that, make sure we've got all the supply voltages. I've written, because this is the other thing that is difficult in complex gear like this. Okay, so we've got to check 225 volts, positive 225 volts, but where is it? So I've been through the manual and found out on which pin, on which card and all the rest of it I should find that, etc, etc. These ones I haven't done that, so somehow I'm going to have to try and find out where Q404 collector, base and emitter is, and where I can get a probe onto that, because the transistors are in these like sort of bases, and obviously if I start probing around in there and then like say hit that to there, then that's not going to be a good outcome. So I need to find like say the nearest resistor or diode or whatever junction so that I can take the voltage. I shall go and do that off camera, A, because it's boring, and B, I need to concentrate. Well, here we are in the living room looking at the schematic of the output board, and I'm slowly starting to get my head around this. This is a complex circuit for me, and transistors aren't my strong point. So what I've been doing basically for about 4 or 5 days is looking at the schematic, reading the circuit description, trying to make sense of how it works, etc. So essentially, as far as I understand it, we've got our signals coming in here from our output cards. All the attenuation, gain and everything is taken care of on the output cards. We've got a variable volts per centimeter pot here, and our little preset gain pot there. Let's ignore them. So basically it's a pretty simple balanced front end. We've got part of the signal here, part of the signal there. They get amplified or whatever, and on we go. And then we've got the positioning pots. There are 2 of them. This is channel 1, channel 2. Whenever you've got a complex problem, the clues that you need to fix a thing are right there in front of you. You just got to get your head to work. So a lot of the time when I'm sort of floundering around and I find a circuit that doesn't work, I start by the sort of standard, check all the transistors, diodes and etc to see if they're okay as a first thing, and then after that you really have to start getting your head around it. So as far as I can see it here, we've got minus 150, and as we saw the other day, that is dropped by this 12k resistor, and so we've basically got 100 volts here, 100 volt, minus 100 volts there. That will basically position the trace up or down by making one side more positive and the other side more negative, or vice versa. Okie doke. Then we come through a series diode here. These diodes here are important, but not just now. And then they go over to this output driving stage. The output driving stage is very simple. I'm going to blow it up. It looks complicated. I don't know. Sorry, a bit of it. So all we have this valve here, except it's not a traditional valve, it's called a new vista, and that is a new vista there. It's basically a very small valve. In this metal package there is a glass valve in there, but because it's so small, the various electrodes are small too, and thus the capacitance between those electrodes are small, meaning that these little new vistas could operate at higher frequencies than a lot of valves could that had a larger physical construction. So we've got this new vista here and this transistor here, and they are working in a cascode. What is a cascode? These two, this valve here and this transistor here, V464, Q464, are essentially like a pentode. So if we put an alternating current voltage here, this will make the current flowing through this transistor go up and down, and it will modulate or make the current flowing through this valve here also go up and down. So what we get here, we will get out here, but more so. It amplifies it. So it has a higher gain than a normal, say, common cathode voltage gain stage. Our outputs from both of our cards, channel 1 and channel 2, come through this little, where do you call it, inductor here, centre tapped inductor, and one side goes to this base here, and that makes it modulate and thus amplifies our signal. We're not interested in the AC conditions though. What we are interested in is this figure here, 67.5, and we should have 67.5 there, because if I just make that go smaller, they go out here. This is our connector to our oscilloscope. So this pin 3 and pin 1 go to our vertical plates on the cathode ray tube of the oscilloscope, obviously through circuitry, you know, attenuating gain sort of circuitry to drive the plates in the cathode ray tube. What we have here and here will affect the position of the trace. When I took the voltages the other day, if I can find all my notes, I'm keeping extensive notes. I'm keeping a lot more extensive notes than normal, because what I often find is I come back to notes that I've written years before and I haven't a clue what they mean. So I've written down what I've tried here. These are the voltages that I took yesterday. On pin 1 we had 68.7, and on the pin 3 we had 67.7. When I was reading the circuit description, it said that 0.6 of a volt either way on those two voltages that I've just given there would make the trace go up or down. As the trace is stuck up, it's stuck up here, that would make sense. Because this is stuck up there, look, that's making the trace stick at the top of the cathode ray tube. Also what I found was that when I varied the position knob on the front of the vertical plug-in, these didn't change. These two values didn't change. So what could be the problem? You see, what happens here affects what happens here. So we need to get our thinking caps on it, else we'll be here all fucking day. Is it this circuit here causing a problem here? I don't think so, because our position problem is the same whether we have channel 1 selected, channel 2 selected, alt or chop selected. So I think we can discount this bit here. The problem is here. So after taking those voltages yesterday, sorry this is so long-winded, but I have a lot to explain. Anyway, so what I did, I swapped these two new vistas over yesterday. The problem remained. So now what I'm going to do, we've got like various voltages written as we go up. So what I've done, I've drawn the circuit out with all the voltages on at where the various resistors are. I find that drawing the circuit out a lot of the time helps me to understand, or gets my brain thinking on the sort of right line. And the other thing you have to get your head round a lot of time, like in electrical circuits, it's easy to get caught in the trap of thinking in terms of voltages. So like, you know, when I take DC conditions on an amplifier, but all those voltages that we take with our meter just indicate to some extent, or to a large extent, what current is flowing. We have to think in terms, you have to think in terms of current. So why is the voltage up here stuck, and why aren't the controls making it, you know, changing the DC conditions so it changes the trace? Obviously it's stuck up here for a reason. Why? There must be more current flowing through this part of the circuit because the voltage is lower. If we've got more current flowing, the voltage drops. You can just think of this, the whole thing, in terms again as a voltage divider. We've got a voltage here and here, load of resistors. Yes, we've got transistors and valves, but just think of a valve or a transistor as a variable resistor. That's all it is. And then the other thing I've done, I have another 1A1 type plug-in. This is the output card off there. Beautiful, isn't it? Absolutely beautiful. And then so what I've done, the problem I have a lot of the time when I go to take various voltages, you can't find R464 or whatever. So I've gone over the whole thing using this picture here from the manual with all the components written on, and I've identified before I go and test in that cold workshop where I need to put my meter probe to find the voltages that I want. This is the trouble with PDFs, like on a screen. With a book you can flick through. I can go from like page 10 to page 210 quite quickly. On a PDF on a computer it takes time for the computer to load the pages, and it takes time to find the pages. With a paper manual you can just find everything instantaneously. So now we know where the voltages, where we need to put a probe to check the voltages. I'm going to go into the cold workshop and do that. I was able to take most of the voltages, however, because this is unlike a sort of typical transistor sort of circuitry that runs on low voltage, this runs on high voltage. So we've got this wire here that goes to our pin 3, and then I hope you can see sort of down there that where do you call it, resistor is what we need to bob onto to measure our voltage on the new Vista grids. And so it's off at the moment. I was very reticent over sort of doing that, shorting that to the base there, or that, shorting that to there, and killing the new vista. So what I'm going to have to do is put, if I can get in there, some sort of probes like this before I power it up. That's insulated. And there we go. Right, so what I shall do, I shall power it up again, and so far most of the voltage readings that we should have aren't too bad. I've got 67.8 here, should be 67.5, so yeah, a little bit over. But this one is a lot over, this 68.4. Well, I've made a real tit of myself. If we go and have a look at the, where do you call it, the oscilloscope, I will try and explain why I've made a complete tit of myself. Follow me. So as you can see, we've got traces on the screen. If I just take out the square wave, channel 1, channel 2, it's got that much glare it's hard for me to see what you can see. I'll just turn the intensity up a tad. Channel 1 position, channel 2, working on chop. Does it work on out? Okay. Right, that's channel 2, so where's channel 1 gone? Right, so we've still got problems because channel 1 is not working on out. What about add? Yeah, channel 2. There we go, that's its mid position. Channel 1, mid position. Everything's groovy. Let's try and find out why. This is my other 1A1 plug-in. As you can see, there's a load of wires. Here's the output card. That goes in like that. Okie doke. And then you've got wires. You've got wires that plug in. So where are we? There's a big one for the ground. There's the ground. We've got a big one for the ground. That's there. This is that would be pin 1 or 3. I can't remember. Pin 1, pin 3. Got this. Where do you call it here? Pin here. I'm not quite sure what that is. We've got some others. So anyway, as I was trying to position the card when it was in, so the card goes in like that. As I was trying to find a good position to put a probe in, I noticed that this wire wasn't on. So I got pin 1. So that's pin 1, pin 3, got another one down here, but this wire wasn't on. Put that on, and with a little bit of tweaking, sorry, God, every bloody things, with a little bit of tweaking of the attenuation balance, the traces came good. Well, that's a real puzzler. Let me show you my notes. So these are my notes for the various plugins. I was checking the CA plugin. This is the plugin we just looked at, which is serial number 101091. Up and down not working. No alternate, or I presume that is chop or add. This is the one we're doing. which is in the, this is the one that's in the scope. No up and down, nothing works. And then I remember now, I tried putting a square wave in, so the trace was stuck right at the top of the screen, and I put a square wave in. You could just sort of see the square wave. So how the hell has that fixed itself? So on the other plug-in, I went over, as mentioned previously, over all of the diodes, you know, doing a check on diode check, and then I checked all of the transistors. And then the other thing I did was to reseat, or just sort of wiggle the transistors in these bases here. That might have done it, but yeah, I don't know, it sort of fixed itself, which I'm really chuffed about. The thing is, like, which you have to remember if you're ever fixing any of these old Tektronix 500 scopes, really there's not a lot that goes wrong. I don't think I've ever found, I mean, I found out of spec resistors, but I have never found any of the resistors or capacitors, apart from like power supply capacitors, that is, I've never found a component wrong in all the years that I've been mucking about with them. So the only thing that can go wrong, you see, like here, look, these have obviously had some replacement transistors. They should be this package, and they've replaced them there. You can see how that one, look, it's a bit wobbly, but you see, I went over all this. So on the other output card, I cleaned up a joint that looked a little bit iffy because it had been worked on, as has this one, but for, you know, the age of the scope, that is pretty normal. So that's brilliant. So you could say, well, what a fucking complete and utter tithead, what a waste of time. However, it wasn't wasted, because one thing, and I've learnt a hell of a lot from trying to get my head round these plugins. I've learnt how they work, and they're really, really clever at how they work. I'll just run this past you, like, for in the future, if anybody's got one of these plugins that doesn't work and doesn't really have an idea how things, you know, are set up. So you basically got these transistors down here, your signal comes in, this is your first stage, and then this is the point where the, just sort of prior to these diodes here, these are all diodes, prior to these diodes here, this is where your connections go to your potentiometers, your up and down potentiometers. And so in channel 1 mode or channel 2 mode, you know, it's just, there's no switching of the time bases, switching from channel to channel, as it were. And then you've got these two transistors here, and what these form is what is called a multi-vibrator or an oscillator. So what will happen is one will switch on, the other one will switch off, one will switch on, the other will switch off. And then what it does, it's clever, it uses these diodes here. So we've got some signals coming in into these transistors here. All your chop or out mode does is switch from one channel to the other. Boop, 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 boop. And to do that, it uses this multi-vibrator to bias these diodes here. And so some of these diodes, I think there's 4 of them, because remember this is like in a balanced stage. If I look at my really atrocious thing here, one moment. So I know it's a bit messy, but basically we've got the whole, and most oscilloscope front ends do this, they run a balanced circuit. So you got one input coming in there, one input coming in there. so it's balanced. It's not just like sort of single-ended, it's like a push-pull circuit but all the way through. So what it does, that multi-vibrator, all it does is biases these diodes either forward biased or reverse biased. And essentially what that means is when it wants to jump over to channel 2, these will be biased so they're across the signal, and we'll just turn the signal off on channel 1, and then the opposite will happen when we want to show channel 1 and not channel 2. So by using these diodes, they're called shunt diodes, it is just basically forward bias, reverse bias, forward bias, reverse bias, etc. And then all that does is just turn one output or the other off and on, and then from there our signal goes over into our output stage, which is here. And like I said, that's a cascode circuit, and that drives the scope into displaying the traces. It's pretty simple when you look at it, when it's all boiled down to it. A lot of these other components and whatnot are just there for AC compensation, so that we can see the signal at all frequencies, you know, at a flat level, so there's no real roll off until you get quite high frequency. Well, thanks for sticking through all of that. As you saw, like, it is very easy to forget something like a wire, which makes your life harder. However, I'm not bitter about it, because like I say, I've learned a hell of a lot, you know, by going through and learning about how this particular plugin, and I suspect how most of the sort of plugins, and as a consequence of that, most sort of vertical front ends of oscilloscope work. It wasn't time wasted at all. My videos tend to be a bit long-winded, because a lot of the time you have to remember I don't really know what I'm doing. I mean, I have some basic sort of idea of how electronics work, but what you have to remember, a lot of the time I'm exactly in the same place that you are, probably a little bit further on, about learning, you know, about electronics. And it's like the little bird in the mountain. There's like I don't know if you know the story. There's like a young lady and a chap who's in love with the young lady, and he asks the young lady to marry her, and she says, yes, I'll marry you, but when you get this small bird to chop away at this mountain and the mountain's all gone, then I'll marry you. So electronics is a little bit like that. You just have to keep pecking away at it slowly, you know, you'll get there. So yeah, I hope that sort of offers a little bit of inspiration to some of you that struggle with this. I struggle with it too, and if I can do it, I'm not particularly clever, you can do it. So lastly, I'll finish off by waxing lyrically about these lovely 500 series Tektronix plugins. I mean, look at them. They are just like the 500 series scopes, they're just beautiful. There's one particular thing that is really amazing. Right, so if I show you, see this switch here? Right, what that is your attenuation. So we're at the lowest setting here. So what an oscilloscope front end does, let me just pull you back. What most oscilloscope front ends do, when you've got a really big signal, they'll use resistors and whatnot to make that signal smaller, and then when you've got a really small signal, they'll use the gain, you know, a gain stage to make that signal bigger, so that as the signal goes through the vertical sort of circuit, it arrives at a place where the voltage coming into, like say that output cascode that we saw, is all of the same amplitude for, you know, whether you stick in 5 millivolts in or 50 volts. As I mentioned, these have this amazing, this is the attenuation, and so if I move that, it's a bit hard to show this all in one frame. So as I move that, you see the switch isn't moving. So we're now on 10 millivolts per division, 2 millivolts per division, 50 millivolts per division, and you see that? It's only when you get to 100 millivolts per division that the switch starts to move. 1, 2, 3. I mean, look at that. And so if you look in there, I mean, this is amazing. Look at the gearing and the engineering that's gone into that, and the thought that's just gone into just like what is essentially a switch. And then you've got this capacitor in this housing here, and this, look at it, look. It's all rubber mounted. Gold like plated pickups, ceramic wafers. I mean, what isn't to like about that? That is silver. I mean, it's tarnished, but that is either silver plate or bloody solid silver. I mean, these things cost a hell of a lot of money back in the day, and I hope I've shown that they are still useful, especially, you know, when you're messing about with valve amplifiers. Yeah, it's dusty, but that don't matter. I ain't gonna start messing about with that. A lot of folk like go overboard on cleaning. I ain't bothered about a bit of muck. So that's the type, let's get you back in. That's the type 1A1 dual trace plug-in. Before that, most of the 500 series scopes came with this plug-in, which is a CA plug-in. And as you can see, it's still the same sort of construction, but we've got loads of valves in here. And if there's any of you out there thinking, oh, I'll get one of these plug-ins cheap and use all the valves, you're wasting your time. These scopes have probably been sitting in a laboratory on for 24 hours at a time when they were, like, you know, in service. So the valves will be well worn out and tired. They aren't worth bothering, and I've done it. I've tested valves out of these things. Yeah, and they're not at the best. So don't go thinking if you get like a 500 series oscilloscope you'll have lots of lovely valves worth loads of money or whatever. You won't. Anyway, as you can see, this CA plug-in has lots of valves. I don't know if there is any transistors. I mean, these evolved over the years. As you can see, it's the same sort of ceramic wafer construction, bit of dust. The attenuation front end here is a little more primitive than the 1A1 that came afterwards. This is our 100 nanofarad capacitor. That's when you click on the AC coupling, that's stopping DC going into the plug-in, and so yeah, do not exceed that. Here's another one I've got. I'm fortunate to have a few, but I've been collecting a few years, and that's got again a few valves, sort of less so. And this one is a type L plug-in, which has a very fast rise time, and yeah, it's a completely different beast to the CA sort of plug-in. I've also got a type G as well, and so now that I've managed to fix that other 1A1, I shall have a go at these other ones, because it's not as daunting now. But yeah, I mean, look at the work in there. Isn't that just beautiful? These should be in the fucking Tate Gallery, not fucking Damien Hirst, or, I mean, I love the woman with the bed and everything. I mean, yeah, Tracy Emin, but fuck's sake, that ain't art. Jesus, this is art. Anyway, I'm going to stop waffling. Bit of a long one, lads. Hopefully somebody in the future when they're struggling to get one of these plugins going, will look at my video and find it useful. If that's the case and it helps one person, then my job is done and my life is not wasted completely. Thank you all for watching. Take care of yourselves. Ta-da for now.